Good morning and welcome. My name is Michael Finnegan. I'm the Director of IoT Business Development here at MultiTech. I'm really pleased to be sharing with you our LoRaWAN overview. LoRaWAN is a very popular topic right now. And in today's discussion, we're going to talk a little bit about various technologies and how they fit within the marketplace. So we'll discuss a little bit about what LoRa is, where it fits in the marketplace. We'll also talk about our gateway strategy as it relates to our end nodes, and we'll also talk a little bit about the platforms themselves and the support of mLinux, and also our application execution platform. In addition, we'll also talk a little bit about the deployment strategies with the LoRa servers, whether they reside on the gateways or within the cloud. And then we'll also talk a little bit about device management and ultimately other options to be able to deploy in the marketplace using low-powered wide area networking. So a little bit about MultiTech. MultiTech designs, develops, and manufactures communication equipment for the industrial Internet of Things. We help take physical assets in the business world and be able to deploy usable information so that you can guide your business and get value that's happening in the marketplace. So effectively, we help enable these various vertical markets with taking information and be able to bring them up to platform as service. We've been doing this for over 47 years with various technologies we've invented and brought to market. So let's talk about low-powered wide area networking, one of my favorite topics. So to give some examples of low-powered wide area network, I thought maybe we'd talk a little about some use cases that are out there today. Now, some of these use cases could have been done easily and deployed with other technologies. However, there's a unique value proposition in using low-powered wide area network, which we'll discover as we go through the technology and talk about it. So Enphase, a great customer of MultiTech's, they make solar inverter panels. The business model behind them is that deploying these solar panels has a cost-effective solution for customers, and then there's a way to pay back for the inverter, the panels, and the solars by selling the energy that's used back to the utilities market. This is what the inverters do. Communication is key to making that happen. In the past, cellular has been deployed. However, there's a thought that that cost is a little bit too high of a cost for their bill of materials. So they're looking at new options to be able to aggregate data locally and be able to deliver it out to the network. So Enphase has looked at using low-powered wide area network, our mDot solution, in their inverter panels and in multi-dwelling units be able to aggregate that up to a local gateway, allowing more units to be able to be connected and be able to deliver up to platform. So a great way to use this low-power technology to aggregate the tiny data they need and be able to deliver to the network. So that's one use case. The second one here is an interesting one that's used in agriculture. So a friendly company of ours called, or a friendly customer of ours called WaterBit created a solution that creates a water probe that senses how moist the ground water is and then communicates what level the moisture is within the ground out to platform to let growers be able to have command and control of their networks to be able to optimize and be able to improve their harvest. We'll talk more about a field trial that was used with WaterBit that's very specific. And lastly, a neat little company out in Ohio, a startup called LoRaTech. They created a digital signage solution using an e-paper solution. The ability to take a large file, about 20 kilobits, be able to compress it and send it over this LoRa network to be able to refresh these signs and be able to have this in a private instance. Really interesting solution here, because typically when we look at low-powered wide area networks, we think very small amounts of data, not digital signage. However, here's a perfect example of a low-powered solution using this e-signage solution to deploy and using a low-powered network to do that. So let's talk about the drivers here, right? So connecting things to the internet has not always been easy. We've got challenges out there. But I think we are at a point in time in the market that we can overcome those challenges. So here are some of the challenges that are out there. Things have to be on batteries for up to 7 plus years, right? So we need to be able to have them connected using low power solutions, because you can't afford to have a truck roll to replace batteries on a regular basis. So you really have to be conscious about the way that you communicate. It has to be low cost. It has to have really good range and penetration into buildings. It also has to be able to have some intelligence and have decision-making capabilities directly on the edge. And then the ability to ease program, time to market, security is a must, and remote management. See, it's a highly fractured market. We have lots of requirements in delivering these solutions. And so we need to have a tidy form factor that has some intelligence on the edge. And I think we have a really good answer for some of these challenges. The answer to those challenges is a low-powered wide area network. So let's talk about some options that people have. There's a whole bunch of options as far as connectivity is concerned. So we have LAN, cellular, and now this new category called low-powered wide area networking. And really what we're seeing is a bleeding of these technologies. There's not one particular scenario that will be delivered. I think we're going to see a hybrid of many of these solutions as they get deployed in the marketplace. And I could give lots of examples of where you might need a Bluetooth and a cellular and maybe a long range all in one particular device. However, that's not always cost effective, right? So let's talk a little bit about these different areas. LAN area is great for the short range. We've got various technologies. Some examples here would be Zigbee, Bluetooth, and Wi-Fi. These are great short range solutions. They are great for mobile, in-home, and we use them all the time. However, we also know that they're not very good for battery life, and they certainly don't have the amount of range that we would like to have. So it has its use case, but isn't always a good fit for macro area networks. Cellular is a macro area network. It's ubiquitous. It means it's everywhere. It has high bandwidth capabilities, high data range, very good coverage. Challenges, as we all know, walking around with our mobile phones, you're always hunting for, a place to plug in to charge. So, not so good with battery life. New category we have, some examples of this low-powered wide area network might be LoRaWAN, maybe Ingenu, Sigfox, or Weightless. These are a couple areas of low-powered wide area network. These are very good for long range, very good for battery-powered solutions. Also, they're low cost. The challenge is they're not very high data rates. So somewhere between these three different categories, you're going to try to mix and match and come up with a perfect match for your solution. We think we have a pretty good answer for how to do that hybrid network, and we're going to share that with you as we start talking about our conduit gateways and our mDots. Let's talk a little bit about the technology first, right? When we start looking at consumption, we asked some good friends in the industry, well, what's being deployed today? So our friends at James Brennan Associates took a survey of about 3,000 customers. And in those 3,000 customers, what we found, and they were cellular-based solutions on the monthly recurring basis, we looked at utilization. And utilization, I was shocked to find out that only 4% had 10 megs or less worth of utilization. And then as we started looking at the next category, 11%, 3 megs to 10 megs, 11%, 2 megs to 3 megs, 6%, 1 meg to 2 megs, 4%, and an astounding 75% of these surveyed customers use less than a meg a month. What does that tell you? What it tells me is that they're not using the cellular-based product for the bandwidth that they need. They're using it just for tiny telemetry needs. My question is, could that be served with another technology? Well, I believe it can be. There's going to be large growth rates throughout the marketplace, lots of growth that will happen in the unlicensed spectrum area. There'll be lots of growth that will happen in the cellular-based scenario. And here's an interesting forecast by 2020. This is just looking at industrial IoT, by the way. I should remind you in this slide. But what's interesting is that we're seeing a real big growth curve that starts here, and It's a little aged at 2015 statistics, around 78 million low-powered wide area network deployments, but it will grow by 2020 up to about 900 million in just 3 short years. So massive growth will happen in this category, fueled basically because, cellular isn't a really great option for some of these deployments. Now, I say that in this slide. However, there are some directions in where cellular is going that it might be a pretty good scenario. So I'm kind of hedging a little bit here about these growth rates. I mean, growth is a good indicator of where we see markets are going, but really what we're looking for is results. And so let's talk a little bit about how we can move into actionable data and why. So LoRa, we've created a product with some best-of-class partners. And so I'm really proud to say that we partnered with Semtech, the patriarch of this technology for LoRaWAN, ARM, and also IBM. So this three-legged stool helps create some really interesting value propositions, right? So the Semtech LoRa chipset can support up to 10 miles outdoor range and 2 miles indoors. ARM brings processing power and capabilities locally onto that board so we can create a system on module. And IBM brings the software and platform capabilities to help us monetize and bring that value of that data up to a meaningful level. These three logos in combination, or partners of ours, allow us to create a really good value proposition with our devices. So what is LoRa? LoRa is a standard, I think is a better way to say it, right? So the LoRa Alliance has well over 400 contributing members contributing to this standard and a rollout that's truly available worldwide. And so we have lots of input. So LoRa is taking a look at various RF technologies and combining them into one consumable package. But let's talk a little bit of how that's deployed, right? So in doing so, we'll compare and contrast with some other technologies to see about range. So when we look at the range of some of these technologies, in the short range category, you got Bluetooth and Wi-Fi, and maybe Zigbee kind of crawls into that space a little bit too. Let's call it 300 feet up to about 1,000 feet, right? So, and that has its use cases. However, I would say that as you move beyond 1,000 feet, you need to have some other ways to do that. So there's frequency shift keying, which can get you up to 2 miles. But frequency shift keying has some challenges in itself because it can be stamped out because of noise. What's really interesting about the LoRa standard is that our friends at Semtech have done a really interesting job with their modulation to be able to include elements of frequency shift keying and the elements of LoRaWAN. So that it's resistant to noise. We'll talk a little bit more about that in just a little bit. But impressive as we start looking at LoRa to have at least up to a 10-mile range in optimal conditions, right? We'll get to some real field trial information to kind of show you the difference between maybe the data sheet and what happens in the market, because it really depends on how you deploy. So briefly about the technology itself. So again, it's a spread spectrum technology. It's a chirp spread spectrum technology. It's actually kind of interesting to note that this was designed or taken from nature, right? So a study back in the early 30s of how dolphins communicated, right? So there's a research about how it was developed and looking at how that communication pattern happens in natural surroundings and was adopted into a technology that was leveraged by the U.S. military for battle communications that was secure and impervious to jamming and decoding. So that was brought up, and then it was shelved for a while. It had a resurgence in the 90s as a valid communication method, and then now enjoys a very big resurgence in deployment. So let's talk a little bit about what that is. Right? So it's a spread spectrum technology, and it operates below the noise floor, which means that if you're in a heavy, noisy environment, this is a great way to be able to deploy without having your signal stepped on or jammed. in the past, if you had just frequency shift keying, you would operate above and right in a narrow band right above that noise floor, and you could be easily stepped on by other frequencies within there. But since we're operating below the noise floor, you're not going to be able to have that interference or jamming that's usually happens with some other 900 megahertz spectrum radios. It has better sensitivity than just plain frequency shift keying. It's more tolerant to this interference. But the neat part about it is that it has the ability to have simultaneous occupation on the same channel at the same time. So how do you do that? Well, there's an adaptive data rate that allows you to support that. So you can have things operating in the same frequencies at the same time without having any problems. In other words, you could actually have two LoRa networks simultaneously working at the same time. One could be public, one could be private, and the two would operate seamlessly. Now bandwidth, right? So here's why it is a pretty efficient technology. We take a look at the entire spectrum, and there's multiple bandwidths that can be used at the same time. And so the SX1272 chipset by Semtech that we use in our product has some great capabilities. One of this is the use of 3 different bandwidths to be used at the same time. That makes it very efficient. So it uses 125 kilohertz, 250 kilohertz, and 500 kilohertz. In the United States, according to FCC, we can only use 2 of these at the same time. So there's a little bit different data rates between European deployments versus US deployments. However, it really doesn't matter because it's tiny data and supports what's needed for the application. But the point here is that each of these bandwidths could have multiple data rates at the same time. So here's the example of how that works in the reality. So base station controller directly in the center where your large antenna is. And as you go out, there's multiple spreading factors that can be used and communicate up. As you get closer to the base station controller, the more spreading factors you might be able to use, and of course, the more bandwidth you can have. And as you go further away from the base station, the less spreading factors you're going to be able to take advantage of. So we can never pin down exactly how much your data rate is going to be. All we can say is there's a range depending on your deployment. So the range here, for simplicity's sake, say 300, well, it's 292 technically, but it's about 300 bits per second up to 20 kilobits or 50 kilobits per second, depending on if where it's deployed. So lots of technology options inside here. So it's a bit of an eye chart. However, what I really want to share with you is, although there are multiple low-power wide area network options that are available today, there's really only one that's truly a standard. And so based on the LoRa Alliance, that would be LoRaWAN. It's available right now. It's generally available. And then there's others like Sigfox and Ingenu. They all have their pluses and minuses. But one thing I want to highlight across all this as you start to research this is you take a look at your max data rate and you compare those across the line. And you look at the actual power out or link budget across all these particular devices. And lastly, power efficiency. And so those are the big categories you really want to kind of take a look at, because that's what's really going to help you design your network deployments. So you've got options here, right? So I won't go through all these options, but I will say cellular does play a very important piece here, whether it's an aggregation technology or it might be a deployment for low-powered wide area networking. You see, LTE has had a departure from its large bandwidth solutions that have been deployed, and now has capitalized on some of the Internet of Things and looking at narrowband solutions. Today, in LTE, there is a Cat 1 product. It fits a very specific marketplace, but here's the challenge. When you compare and contrast, its power efficiency is relatively low compared to the high efficiency or very high efficiency you can get with LoRaWAN. So what does that mean? That means if you're running off a battery, really this is not going to work for you, okay, with a Category 1. Until you move into the next categories called Cat M1, And also this next area called narrowband IoT, which is still being ratified in the 3GPP specifications. That's where you start to get medium efficiency to high efficiency in a licensed spectrum form factor. We still have a cost difference that we'd probably take a look at. Until we get to a narrowband IoT, it won't really match the pricing structure that we're seeing with low-powered wide area networking. So there is a time to market advantage right now for deploying LoRaWAN. It's lower power, it's efficient, it's available now, but more importantly, it's one of those areas that you can work in a true CapEx model versus an OpEx model. And what I mean by that? So the OpEx model would be in a cellular-based solution where you buy a product and then you use the macro network and you pay for that. And the scenario with low-powered wide area network, you can create your own infrastructure very cost-effectively, and then you pay it once in a CapEx model. And so there's no monthly recurring fee, potentially, here in this LoRaWAN category. But I will say this, there are macro networks that are being deployed, so if you don't wish to own an infrastructure, you can pay an OpEx model with LoRaWAN today. There are several really nice providers out there. Senate is the one that comes to mind, and we've got others that are throughout the United States that are coming into market. So there are options for you, but my point is you have a way to be able to do a CapEx or an OpEx. Applications. Let's talk a little bit about applications. A quick little look at this. Naturally, security products with high resolution video is really not a good fit for this low-powered wide area networking. That's where you'd probably use an LTE product. In medical devices and maybe home automation, this is an area where you might use a cellular product, but you'd probably use an unlicensed band in another area. But really where we're seeing deployments of low-powered wide area networks is when they're in remote areas that need battery power and tiny data, in areas where you have like tank monitoring or maybe facilities management where you don't own the building, but you want to manage aspects within the building. You need to be able to create a kind of a drop-in network, if you would. Smart parking and agricultural assets are natural fit for this technology. So smart cities, metering, submarine parking, security fire alarms, agriculture, environmental sensors, and building management. I love this slide because it reminds me of the architecture and the way that people can deploy quickly. And so there's lots of ways to do this. I'm going to go through this slide talking a little bit about the security elements here, but really what I'm going to talk to it as if you're developers and you're creating your own applications. And this is where the advantages of LoRaWAN come in to other LPWA solutions out there today. It's an open architecture, meaning that you have the ability to control that architecture and be able to play in whatever elements you wish to. Unlike other LPWA solutions like Sigfox and Ingenuity, those are closed architectures. You really have to use their product in the way that they want you to use it, and you don't control the application, they do. So I want to highlight that as developers, this is really developer friendly. And I'll talk a little bit about where you make your money in these various categories. But first, let's talk about security. LoRaWAN has a protocol that it has security built into it. 128 AES encryption in the payload, secured from the node level all the way up to the application level. Very secure, great way to be able to deploy. Security is covered. We actually add additional security in our modules, which I'll talk about in a little bit. That being said, here's the deployment architecture. You have end nodes, which have these lovely radios in it that uses this chipset that Semtech has provided. We license that chipset and create a very consumable SOM, or system on module. We call it an mDot or an xDot. These dots go into various products, whether pet tracking, smoke alarms, vending machines, trash compactors, trash collection, you name it, lots of things that are out there that need to be monitored. Low cost, low power solution goes inside there at those end nodes. Then those communicate to gateways or base stations if you wish, right? To be able to create a macro network we designed a gateway, which we'll talk about in a little bit, called the conduit. The conduit is just that, a conduit to take the data up to platform. So in our conduit, we have options for a deployment model, and I'll talk about that in just a moment. From there, we usually take these end nodes and have them associate with a join server. That join server manages the security and the connection of all those dots coming into the platform. Now, typically, people will deploy that in the cloud fashion. However, that's a pretty big investment for some folks to be able to create their own cloud-based join server out there. So in true fashion in product management, we wanted to make it go faster to market and help this nascent industry get off the ground. So as a deployment option, our gateway supports the join server to be put directly on the edge of the network. Why would you do that? Well, sometimes you just need to be able to control a small area network, like a campus or perhaps a neighborhood area network, where you could deploy this join server where a couple thousand nodes can connect to that join server locally, and then using Ethernet or cellular backhaul, take that and have that information using MQTT or other ways to communicate that directly up to the application servers. Other option is, as you grow between one campus or maybe one neighborhood area network to maybe 5 or 10, well, it becomes kind of an administrative burden to have all these individual join servers out there. Maybe at that point it makes sense to take that join server and place it in the cloud and aggregate that and become your own macro network. Makes sense, right? So then for there you have the ability. Now, back to the money, right? So as developers, you want to control your applications. You want to control the logic out there. And you have a way to monetize that application right here at the node level. So at the node level, you can create scripts that are very specific with logic to make that data actionable. Not just pumping data out, but true information that can be used to work with other nodes in a mobile originated to mobile originated fashion. In other words, you could allow communication to multiple nodes right within the campus area network. Very effective. Okay, so you have a way to monetize that here at this area and make some money on the node level scripting language and logic. The next layer is to be able to create an aggregation layer where you can be able to create a script language, maybe over Python or Ruby or Node.js, and be able to own that application to be able to have data happen in the campus area network that doesn't need to communicate all the way to the application server, but could allow node-to-node communication and notification to happen. So this is the true notion of fog networking, where you have processing locally on the edge of the network. And then lastly, as you communicate and aggregate these campus area networks up through to your application server, you've got another way to monetize this. You got a way to do this to take that to a macro level, to really use machine learning, to be able to have analytics, and be able to take a look at a way to holistically look at multiple networks and really derive a lot of value out of your networks. So you got three layers to make your money: at the node, at the concentrator, and at the application server. And we keep it open so you can do that. So talk a little bit about the conduit. Conduit's a great product. It's an industrial strength gateway concentrator that allows you to do your own processing locally. It's a Linux appliance. This Linux appliance has options, right, to be able to run programming locally, or we create a version that's just a straight what we call mLinux. It's a Linux environment on Yocto. And you can develop your own, or you can leverage some of the pre-defined solutions, what we call application execution program or platform, and you have options, right? So either make your own, or you can leverage some of the capabilities that we've already designed. What I like about this particular chassis design is that we have different card options that whether you need GPIO or serial, or maybe an additional Ethernet port, or maybe you need multiple LoRa base station controllers in your device, we can support that in a modular design and build to order. The neat part is about this is that we have a way to deploy and manage and scale these solutions. So at the request of some of our carrier partners around the world, we were asked to take our industrial design and make a more carrier-grade solution. And we've created an IP67-based chassis that allows macro networks to be deployed in urban environments as well as out in agricultural settings. So as promised, our field trial. We worked with one of our good customers called Waterbit. And Waterbit deployed some of our gateways and our nodes in a field trial fashion, and they picked a very challenging area in Madera, California, in an orange grove. Well, this was done in February. It was one of the areas where there's the only foliage that's out there is orange groves, right? So a dense canopy and these large spheres of water called oranges, right? So probably the most challenging RF environment I can think of because, RF and water, they don't mix, right? So here's the deal. We've had out in the remote ends, we had our mDots. They were on a pole about 3.5 feet, maybe 4, almost a meter up off the ground, right? Communicating to the base station controller. The base station controller, or the conduit, was in a box at the top of a pole 30 feet in the air. So what they found is they were able to support a 1-mile instance in one of the blocks within the area, but and then a 1.6 mile and an impressive 3.2 mile deployment. So I have to say, I had a little wager with the CEO of Waterbit, and I'm proud to say that I won the wager as it relates to the deployment of this technology. So what do they get on doing this? What are they able to enable? Well, lots of different sensor capabilities out in the field that really helps growers manage their yields better, right? So taking a look at moisture, flow, pressure, humidity, and temperatures. These are all elements that we can be able to look at and tweak these different things to have a better outcome or better production. As I mentioned, these are our Linux-based appliances. It runs a standard version of Yocto. So as programmers, you might want to know that you can support Java, Perl, Ruby, Python, any scripting language, really. We also create an option for us to have a deployable Node-RED.js version to make this a very fast and deployable model using kind of an object-oriented node palette where you can drag and drop these bits of code directly onto your device or on your palette to create a really logical flow of information. And now that can be set up by programmers, but more importantly, once you've set up your logical flow, an administrator could simply modify these for various deployments to make it really easy. So you don't necessarily need to have a programmer doing all that on the front end. You can actually have somebody set up templates and implement it with administrators. So let's talk a little about the end nodes, xDots and mDots. So one of the first production deployments that we created, a SOM that's out there, was our mDot platform. Really a great product in the market, I'd say almost first to market in LoRaWAN deployments. It has not only does it have the Semtep chipset in it, that SX1272 chipset, it also has a microcontroller. It has an ARM ST Micro STM32F411 Cortex M4 processor. Why is that important? Well, it's a 32-bit processor for you to be able to process, and put your own script, your own programs locally on that SOM to be able to gather things like sensor inputs, analog or digital, and other capabilities to run, logic-based thresholds for those nodes. Now, there's plenty of memory, 512K flash, 128-bit RAM, K of RAM, and 1 meg of SPI flash. So lots of room on this particular module to support a C or C++ application. And again, the modules are certified. Now, what does that mean? So they're LoRaWAN certified, meaning that they're certified through the LoRa Alliance and that they're valid to use and follow the standards of LoRaWAN. In addition, they're FCC and CE certified, meaning that they're consumable, that you can use them in your products today, use our grant to deploy and not have to go through that certification process yourself or be subject to any violations out there. So it's a very big deal. It's a difference between building your own and buying something that's available right now. So the next product that I wanted to share with you is our xDot platform. The xDot platform is the next in line here as far as products that came out from MultiTech. What's interesting about the xDot is we've been able to tidy up the form factor a little bit, but offer a much lower power solution, or I should say more power efficient solution. It has microcontroller on it. Also, it has a Cortex M3 processor. It's a little more power efficient and a little more cost effective. But what's really interesting about this particular product is that we've also have a build option for a secure element. So we have a eSIM solution that can be deployed using Gemalto. So when you need that security identity management, we add that next layer to our product. That's also a nice comfort for those that already know that the AES encryption is in place, but now we know that the device has not been compromised. And it's using a hardware-based solution, so it's compliant with a lot of government regulations. And it's fascinating. Device HQ. So if you deploy assets, you got to be able to talk to them. So part of our product that's included in the cost of our product is device management. Not everybody does that, but we believe it's really important to be able to have command and control over your devices. We also have part of our device HQ is an application store or an app store. So once you've created your interesting application for maybe your gateways, you want to be able to deploy it easily, but you also have a way to monetize that application too. So if you've created a really interesting, I don't know, energy management solution, and you've created maybe a really interesting agricultural scenario, there are thousands or tens of thousands of these conduits deployed today. You can open this application that you've created up on our app store in a public environment, and other people can buy your product and be able to create networks of their own. A great way for you to be able to monetize. But we also want to be able to have command and control of the devices, so we also support some really fundamental features where you can be able to take a look at the location of your asset, know what version of firmware you're working on, what the RSSI and cellular-based backhaul is working, and to see if your nodes are connected or not. In addition, the ability to upgrade the firmware and other applications through the tool is available. It's necessary for deployments. As promised, there is one other product that I want to share. Although I'm really a big fan of LoRaWAN, there are times where you're going to need to have an isolated solution or an isolated deployment. And in true fashion, we support both cellular-based low-powered wide area networking as well as LoRaWAN, low-powered wide area networking. So we created a cellular-based SOM as well, or system on module, called the Dragonfly. It's a programmable embedded module that's pre-certified on carriers around the world. The Dragonfly is my #2 pet project. I love this product. It takes a certified cellular-based module on a board that's very consumable with a couple different unique interfaces. A serial interface as well as a USB interface. Very common and quick to be deployed. With accessible antennas for GPS as well as diversity for LTE deployments, whether it's Category 3, Category 1, and soon to be Category M1. There's also a 40-pin board-to-board connector. I'll show you the next slide that shows that a little more active. But some things to highlight here. On board, the ability to support 16 digital GPIO inputs or 6 analog, and a mixing matching of those. On the back, you can see the Cortex M4 processor right here, and this unique 40-pin board-to-board connector to allow you to be able to add a simple little interface to your devices to get to market quickly using this kind of click-to-play kind of interface. I will highlight that it has 512K flash and 128-bit of RAM, and it uses a crowd sharing application called ARM Embed, a way to quickly get to market and deploy your applications and share kind of best practices out here. This ARM Embed is supported not only on this cellular-based SOM, but on our mDots as well. My point being is that you don't always have to create the application yourself. You may be able to find and borrow code from others to make your unique application so you get to market quickly. So in summary, we've got deployment models for both low-powered wide area network using LoRaWAN, as well as cellular-based solutions to deployment. And the reality is you're probably going to have a hybrid approach. We believe that cellular backhaul is necessary in our conduits to aggregate low-powered wide area network. We also have a point where perhaps you need to have cellular end nodes that are doing one purpose-built thing only. So we're going to see lots of changes in the next 3 years, but we really welcome engaging the developer audience to make that happen. I want to thank you for your time. I want to highlight we've got our regional sales managers distributed throughout the United States, ready and willing to work with you and support you on your applications. I want to thank you for your time today. My name is Michael Finnegan. I'm the Director of IoT Business Development, and I'm really happy that you're investigating low-powered wide area networking. Thank you.